Of Catalyzing Inclusive STEM Experiences 365, or all year round. My name is Linford Goddard. I'm a professor of electrical and computer engineering at the University of Illinois. And we're excited that you're here so that we can talk about the goal, the vision, the project that we have, this NSF-funded grant. So I'll go into an overview of what the goals are of this project. And I'll talk about the STEM clubs, which is pillar number 2 of our 3-pillar approach. So overall goal, so the background and the idea behind this is we want to broaden the participation of students from underrepresented groups through year-round technology and engineering-rich learning experiences so that students can build discipline-specific knowledge, they get an opportunity to work with technology, and they can better understand what careers exist in STEM and possible future majors and careers. So for this project, we have a quantitative goal that we talked in our proposal to National Science Foundation. We had a bold vision to be able to have experiences for over 1,000 high school students in the state of Illinois. And so we wrote our proposal in a way that we're partnering with 24 schools. Each school, roughly 40 to 45 students, will participate in these STEM club activities. And this will provide them with a sustained, intensive, hands-on STEM learning experience that builds technical knowledge and ability. And in addition to this, we also are going to work with the schools to have scholarship opportunities for students to come to summer camps at University of Illinois that are focused on engineering, science, math, and so forth. Okay, so in order for us to achieve the goal, we have certain objectives. So the first objective is that we're going to equip you, the high school, middle school and high school IDEA teams. IDEA is an acronym: Inclusion, Diversity, Equity, and Access. We're going to equip you through this 2-week Summer Institute with strategies and resources so that you can go back and promote your students' interest in and also their pathways towards pursuing a technical career or major in STEM. And we're going to do this by doing this 2-week, 10-day, 80-hour Summer Institute. It's going to teach the knowledge, attitudes, and behaviors, and also provide you with resources and the resources to realize these desired improvements. So part of what you're going to do is have this networked improvement community, and so you're going to be working with each other, not only at your school, but also at the different schools. You'll have this online collaborative format where you can exchange ideas and talk to each other about what's going well and what needs improvement. Your work during the school year is going to include something called Action Research Equity Project. So Megan Pollock talked to you about it last week. This is going to be your opportunity to test out ideas that can promote equity and access in the classroom. And you'll write up a very short summary of the results. And so the goal is to understand ways to improve STEM education and STEM access. Okay, so that's the first pillar. The first pillar is the Summer Institute that you're currently at, this 2-week program. So week 1 was the discussion about micro-messaging to reach and teach every student. And then this week, we're going to focus on the technical content and really work on understanding what projects can be done in a relatively simple manner, but that are really kind of inspirational and exciting for students to do. So the second pillar is that we're going to work with you, the IDEA teams, to develop, to launch, to fund. We're going to work on the funding part and to sustain, because a lot of times you have great ideas and you put them into action, and then you have to be able to have a model that's going to sustain them. So we're going to sustain these out-of-school STEM club or STEM clubs or academies. Now, these can be during lunch, they could be over the weekend, they could be after school. It's really up to you to figure out which format and which sorts of options and settings works best for you and for your students. These STEM club activities are going to provide unique experiences with engineering design. So the idea of taking a project, starting from conception, realizing a problem, and then applying a methodological approach to solving it, and then constantly improving it. So it has engineering design, it has project-based learning, so you're going to explore, or your students are going to explore different concepts in STEM, going all the way from basic math and geometry to basic science, some physics, and then some more really advanced concepts that a lot of the students here wouldn't see until maybe their sophomore or even junior year. And the goal is to have, as I mentioned, 1,000 students participate in these clubs, so about 40 per school. And it's roughly anywhere between, I would say, maybe as low as 40 to up to 120 contact hours. It really depends on how much additional stuff the students are motivated to do based on their basic going through the curriculum. So the curriculum lays out about 40 hours of material for them to do in these clubs. And then there are a lot of ideas for advanced projects or independent type group type independent work to be able to do even more exciting things. The third pillar of this program is to provide scholarships to 228 students to attend these already existing STEM summer camps. And Dr. Laura Hebert will talk more about the opportunities that are out there through the College of Engineering, also through other departments like mathematics that's outside of college, but they're still related to STEM. So we have a lot of summer camps. The summer camps range from 3 days, the residential programs from 3 days to 5 days. Some of the camps are non-residential, so they're for local students who are carpooling in each day. But in general, they provide these immersive college-like experiences where students get a chance to live in the dorms, go through the cafeteria food, go to class on time, sort of be able to get to that point where they're able to see what is college like and is this for me? So those are the overall objectives for achieving our goal. Okay, so I'm going to put this up, but I'm not going to talk about it in great detail. Basically, the motivation is that the U.S. economy needs people who are trained in STEM. There's many of jobs that are out there. However, our students are not currently pursuing it as much as we'd like. I'm going to put this up, but I'm also not going to talk about it. I'll talk about two of the columns. So the logic model or theory of action is basically what inputs are we putting into the program, what is the structure of what we're doing, who are the participants, and then what are the activities that they're going to do, and then based on that, what are the short-term and projected long-term impacts. I want to talk about the short-term and long-term impacts because those are the most important. So some of the stuff that we want the students to be able to do, we want the students to have improved knowledge of, interest in, and aspirations for careers in STEM, and know what the educational pathways are to get there. We want students to have increased self-efficacy. So we talked about this last week. Self-efficacy is the belief in one's own ability to be able to do a certain task. We also want them to have increased disciplinary specific knowledge and skills. So some of the things that the students will learn are how to work with circuits on breadboards, how to do soldering. Soldering is a skill that when I was going through high school, I had an electronics class and I really enjoyed it, and that got me really excited about building things. In college, a lot of times students go through college never learning how to solder. Even in a department like electrical and computer engineering, it's not a required thing, but it's a skill that's useful as a hobby or as an ability to build and test out interesting things. The third short-term outcome is that we'll have improved educator and counselor understanding of STEM careers and paths. So you as participants will be able to go back to your students and talk to the students about what are the ways to get into STEM, what are the opportunities that are out there. Improved educator and counselor attitudes on who belongs in STEM, and also working as advocates for STEM equity and access. So you as participants have been given some of the skills and resources to be able to communicate with your students to get them excited about getting into STEM. Adjustment of practices by counselors and educators so that they're really focused on addressing the acronym IDEA. Inclusion, everyone is welcome. Diversity, we have participation from all parts of the population. Equity, all students have all students have the resources they need to succeed. And access, the ability for students to have these opportunities. So working on the skill set to be able to promote these amongst your your activities. Program impact, effectiveness, and sustainability. So in order for us to have a model that we can translate to other states in the US, so our focus this year is Illinois. We're partnering with 24 schools. Our goal, our long-term vision is that this model will be successful and that we'll spread it to other states in the US. There are many opportunities and many partners that we already have that could potentially implement something like this at other states in the nation. So we want to be able to show that what we're doing has actual impact, that there's measurable outcomes, and that it's sustainable. So the sustainability is probably the most challenging aspect of this. It's going to be different based on different schools, based on different abilities and so forth. We want to publish research results in journals. So we're going to be working with engineering education to be able to say which practices are most effective at improving student knowledge or student self-efficacy or teacher or counselor attitudes and behaviors and so forth. And then we're going to disseminate best practices at regional and national conferences. So those are the short-term outcomes. Those are the things that we're looking for being able to do in the next 2 to 3 years. The projected impact, sort of what do we expect out of this overall program, we want students to be exposed to content and career opportunities that likely they would not have known about otherwise. We want more students participating, or more of the participating students enrolling in advanced high school science and math classes. So one of the measures that we'll use to see how effective STEM club activities are, how effective our Summer Institute is looking at the enrollment data to see are students enrolling in these advanced math and science classes. Are the schools more effective in identifying and addressing behaviors, policies, barriers that contribute to inequities in STEM? So there are certain things that we do. We talked a little bit about unconscious bias. We talked a little bit about sort of equity, being able to have everyone have the resources that they need to succeed. Are there things that are systematic in the schools that we work with, or that in schools in general, that create some of this inequity that exists in STEM? Are schools able to serve underrepresented students in STEM more effectively? And then I mentioned that our goal is to spread this idea through other states in the US. And the final super goal is that we'll have a larger and more diverse STEM workforce. So this is sort of the theory of action. I didn't get in the first 3 columns, but the outcomes are the things that we want to think about. Okay, so now let's talk about the